Ready to go, Paul? Okay, if you could take your seat, we'll get started. Okay, before we get started with the exercise, I just have a couple of things. Okay, first, I think we only have about 40 of the release forms in now. I just want to remind you that we need to have have those release forms in from basically everybody here, simply because this conference is being recorded, and we want to make sure we have your permission to use your image should you inadvertently or on purpose show up in that. So if you don't mind getting those forms in, that would be nice. And particularly it's important for anybody who's actually speaking. Let's see, that's number one. Nahum, you wanted to say something?
I'm Nahum, the co-chair of Session 5, which starts tomorrow at around 10:35 in the morning. And it's going to be a very short session unless you load your papers. Currently, there is only one presentation on the computer. So I encourage you to go and load your presentations as soon as possible so we know that the session is full. Thank you.
Okay, very good. Let's see. Okay, was there anything else? I don't think of anything at the moment. So basically what we're going to do is we're going to morph our groups a bit here, and so we're going to start the exercise in a second, and Paul has been working diligently for, I'm guessing, maybe 24 hours with little sleep to create something really nasty for us. So, yeah. Well, that's right, about 2 years compressed. So we're going to change things a little bit here, and let me see how I do that. Okay. So one of the things we wanted to do is sort of represent how something like this would actually work. And if you recall from the presentations, we've got groups called the International Asteroid Warning Network and also the Space Mission Planning Advisory Group. These two groups are sanctioned by the United Nations, and they're actually functioning now. And so we decided to rename our groups appropriately. And they do essentially what these groups do that we've talked about. Also, we're going to change the meeting locations. I saw just wandering around that the meeting locations in those rooms where you guys had to have really good hearing to hear over the din, I guess. And so we're going to change where people are meeting. We're going to put 3 of the groups into this room, as you can see. And so that would be group number 1, group number 2, and group number 7 are all in this room, and one reason is that they have a lot of communications to do during their discussions, so we want to make sure that that can happen and that the people are somewhat clearly located to do that. The leadership group is going to go to what we'll call the smallest room, and so if people want to just join us up here, I'll take you to where that is. And the rest of you will be in those rooms there. Secondly, if you want, I might mention another little thing. Group 6, we do want to bring in public communication because we think that people, the decision makers, will certainly hear from the public. And we want people who are members of the public to make their opinions known, and also we may want to see what fake news is flowing around out there about this particular thing. So if you would like to participate in that and bring some perspectives to that group, you can switch to that one, and we'll see. As we go along here, we may morph these groups even more, and so we'll see how what Paul has done to us and how what these groups are doing will change. We would like to have more international representation on our leadership group, and so we'll be bringing in Boris Shustov from Russia, and Makoto, and another individual from Japan. And one more, we'd like to have somebody represent China. So if somebody would like to represent, or if a Chinese person is here who in fact would like to represent China, that would be excellent. And so if you are such a person, if you would come down here, and ideally it would be somebody who knows what this exercise is and was here yesterday, but failing that, anybody from China that would like to participate, we're good. You got somebody? Okay, good. So we have somebody lined up. I think we're in good shape. Okay, let's see. I think with that, yes? Yes. Yes, Gerhard, excuse me, Detlef is no longer Detlef. He's now Barbara Jennings. And so, she will be leading that group. It was close. I mean, what? Let's see. And any other things that I've left out before we get started with this thing? Yes? Group number 5, a decision to act. Basically, the objective there is to really look at the information that's being presented and that's a good question. Group number 5, I would think, would be experts who are actually want to make a recommendation based on the level of the threat and the overall consensus, if you will, of the people on that group as to what the leadership should do there.
One of the things we suggested, some of us,
Yes?
was that they represented the scientific technical knowledge, which was woefully absent in the people on this thing.
That would be fine. Do it that way then. So yes, I think something like that, a consensus of the scientific experts would be fine. Okay, and also, let's see, what else here? I guess, as you know, the IWAN and the Space Mission Planning Advisory Groups are exactly what they say. They're advisory groups. And so if you're worried about, they're not making a decision as to what to do here, what they're doing is advising the leadership, as it would be done in case there is a real threat. So just kind of keep that in mind, too. So I think that's it. And I guess what we'll do is turn it over to Paul here, who's got about a 5-minute briefing, you said, right, Paul? That's a little joke there.
Thank you. Please switch to my next presentation. All right, I'm less organized each day because I had to adjust each time. This is an exercise and not real. I need both, thank you. Can I do that like this? No. Let's go here.
Let me just mention this one. Okay. Also, as you know, people outside of this group can participate, and you can too if you are linked into the internet here. We have a Google Docs page that's accessible by way of the Planetary Defense homepage, which is at the conference homepage, which is pdc.iaaweb.org. You can go to that link. You'll find in there a link to this Google Doc, and you can put your comments in. So we encourage you to do that if you're here, or if you're online someplace, or if you're looking at it, a recording. There we are.
Thank you, Bill. And we have, and my team back at JPL have put a lot of the material for today's Inject, the day 2, and we've updated day 1 with all the recommendations that you all made last night. Thank you for everyone who helped boil those down to a series of bullet points. So we've got extensive information on this exercise on day 1, and now day 2 is filled out with the press release, which I hope many of you have seen, and these briefing charts, almost the latest version of these briefing charts, are also on that on the day 2 website. So the website is being kept up to date with this exercise, and that's quite an undertaking. Yes, this is an exercise only. Yes, this is on as many slides as I can remember to put it on. Okay, we've advanced 18 months in our scenario to November the 30th of 2018, and the asteroid's chance of Earth impact is now 96%. Okay, so I've stepped pretty far forward in the scenario because we need to make some very important decisions, and I want to get to that right away. So let me explain what happened here. Okay. So it's all mostly on this slide. Based on the new tracking observations that were taken this week, the date is now November 30th, 2018, IWAN has confirmed that the asteroid is on a course that almost certainly will impact the Earth on July 21st, 2027. The impact date hasn't changed, but that's less than 9 years from now. So time is progressing. We're getting closer to that impact date. The asteroid was brightened just enough to be detected by the Hubble Space Telescope, run by the US, and, curiously, Japan's Subaru telescope, which is an 8-meter telescope. So we've had not just one, but two instruments that observed in that little circle that you recall from yesterday. The asteroid peaked in brightness at just around 27th magnitude, which was just enough to get some observations. And those observations were approved yesterday, right? I remember the decision makers saying, let's go ahead with the observations. That was the right decision. It made a big difference on the impact probability. Now, prior to this week, the asteroid was unobservable, so there was an 11-month period when the impact probability was only 26%. So that's why those observations were so important. And after this week, the asteroid will fade from view again. You remember that graph of the magnitude. So another 11 months will pass before we get another update on the impact probability. So now the possible impact locations are indicated on, oh, by the way, this is the URL, last time you'll see it, URL. So the impact locations, which if you have looked at on the web, are on the new impact footprint. So now we are narrowing down the possibilities, and not surprisingly to many of you, the impact footprint has narrowed down to the eastern end here, covering China, the North and South Korea, and Japan, and by the way, running into the Pacific. It does not, to the mid-Pacific, and then it goes off the Earth, okay? So it cannot get to the Western Hemisphere. The Earth's orientation doesn't allow it. So let me remind you, I showed this yesterday, that what happened is we took observations at this little peak in magnitude. That's 27th magnitude, very, very faint. But HST is capable of reaching that. And so now this is a little white region. The white regions are when the asteroid is observable. And now we have a little white region, and that was critical to get the impact probability to 96% early. Now, if we hadn't done that, by 2020, it would have gone to 100%, yes, but that's kind of late in the scenario, so we needed to know that early. Yeah. Okay, this is a rotating frame view, and we've seen one earlier today, so I don't feel too bad showing this again. But this is the trajectory of 27 PDC in a frame with the Earth blue, the Sun red, and the Earth-Sun line fixed. So what we're doing is plotting the position of where the asteroid is in this kind of curlicue rotating frame, and this is the year 2017. It's discovered out here. It makes one loop by the Earth, came pretty close, and then it does this kind of looping feature, and it doesn't get really close to the Earth again until this final impact dive in the year 2027. So there's this three-lobe feature is reminiscent of the fact that it's a 3 1/3 year orbital period, and those thirds add up. And eventually, essentially, it almost repeats 10 years later. So that's useful to know. And you can also see why when it goes to the opposition point on many of these late dates, it's very far away and therefore very faint. So, but it is observable in this general region, very hard to observe in this region. I've only designated the exclusion zone based on solar elongation. There's also an exclusion zone based on magnitude, so I haven't done that. Perihelion, there's several perihelions here. 2017, this one would be around 2021, around 2024. This is where we would want to deflect it. It's the last perihelion before it comes back and impacts, okay? So by the way, when we deflect it, it's not within an observable range, okay? It's within this exclusion zone, so we can't observe it while it's being deflected, okay?
We'll figure out how.
Yeah, okay. Oh boy, 2018, so it was somewhere, that's a good question, I don't have the answer to that, exactly where. It would be near 2019. Yeah, so it would be somewhere out here. I guess it was somewhere out there, okay? All right, let me move on. Yes?
How did the impact probability jump from 1% to 26 before the Hubble Space Telescope observation?
Okay, that's a good question. Let me just back up to this diagram. The last inject was right at kind of in this region right here. So there was this period right there when it was observed. And those observations drove the impact probability from 1% at this point to 26% at this point. And then it didn't change until it went to 96% here. Does that answer your question? Okay. All right, so physical properties. That's the next great uncertainty we need to know about. I1 has updated its estimate for the size of this asteroid based on NEOWISE observations, and the new size estimate is 200 to 280 meters, because NEOWISE is sensitive to size more than reflectivity, and that means that it's a relatively low albedo, roughly 4 to 8% by my calculation. Also, spectral measurements were made when the asteroid was relatively near in spring of 2017 that indicated that this asteroid is a C-type asteroid. So we know that going forward. Further refinements to the taxonomy will certainly be available when JWST observes it, but it's just been launched and it's not commissioned yet, so that's forthcoming. So also back in 2017, I forgot to mention this yesterday in the inject, radar astronomers had already put an upper bound of 300 meters on the size of the size estimate based on a non-detection at a fairly large distance of 0.13 AU. So radar tried to observe it. It was not detected because even at that distance, a 280-meter object would not be detected. At least I'm arguing that in this scenario. Okay? Yes?
In this time, how was the level of the position? Because it could be smaller in the radar or wrong position. Both positions.
The radar, yes. Our radar predictions were good enough to point the radar. Yes, so there's no doubt that the non-detection, yes, I agree. You have to be sure that you are pointing correctly. Agreed. Let me finish this slide. Photometry and light curve measurements were also made when it was bright in April, but they were ambiguous and a definitive rotation period was not established, so we couldn't really get a good one. Now the magnitude is 22, 23, so it's difficult to do light curves at these magnitudes. Anyway, the non-principal axis rotation is indicated. Okay? Yes? We don't have any information. This is all we have. That's a good question, but we don't have any information beyond this. Okay, now, the Ames folks have also analyzed this new footprint. This is the same slide as before. I'm just putting it in to remind me of what the different PSI zones were and the rules that they were using on the number of people affected in each of the PSI zones. I'm not going to go through this, but it's in the package. Thank you, Lorian. And again, this is the same as before, showing that the three plots which will follow this, talking about the blast damage zone plots, the mean affected population plots, which I find very interesting, and the damage level, which is the most interesting to decision makers. But these are online. So, taking that risk corridor that you saw, I gave that to Lorian, and she computed the following blast zone damage zones and plotted out the PSI ratings, now based on the new size information we have on the asteroid. So there's the distribution that Lorian used on these Monte Carlos is a little more narrow, and so we have more information than before, and in fact, it's larger size, so we've lost some of the smaller size. I guess that wouldn't make a big difference in this plot, because this is mostly sensitive to the large sizes, more or less. Anyway, you can see a few things here. First of all, Beijing here, Korea and Seoul is in here, and Tokyo is in here. There is an offset of this corridor from the corridor I showed earlier, and that is, this is the one to be believed. The one I showed, I was running the asteroid to the surface with no atmosphere. Ames are the experts in atmospheric effects, so these include atmospheric effects, and all of these impacts are at a fairly shallow, well, usually less than 47 degrees, so they're fairly shallow angles. So that's why there's an offset on these. These are the same points, but they're offset from what I showed earlier, okay? Did I get that right, Lorian? Is it more or less? Okay. Yes. So, by the way, yes, I gave Lorian 100-kilometer altitude, and then she ran it through the atmosphere, whereas the other ones were at 0 kilometers altitude. Yes. Tsunami is included in these, in the following plots. Yes, tsunami is included. Yes, that's coming, that's coming. Okay, so let me go to that. The mean affected population is by color, and so you can see over the ocean, there's not many people affected directly, and that includes, I believe, correct me if I'm wrong, that includes tsunami effects. Okay. Yeah, I think, I'm sorry, Lorian. Please repeat that with a microphone.
So there are some minimal tsunami effects included in here, but they only occur when the impact is close enough to shore that the blast actually ends up affecting more people than the tsunami inundation. So we do get a little bit of tsunami, but it maxes out at about 212 people, I think, in this case, and the blast is more, so.
So hold that microphone while we go to the next slide, and perhaps you can describe this better than I, because now we're talking about affected population, which is, how would you define affected population? And then what are we looking at here? I guess this is a probability as a function of the numbers in a log plot.
Yeah, so this is a logarithmic scale histogram just of the number of people, the probability of the different damage levels of different numbers of people affected. And the affected population is either the greater of the tsunami, which never happens in this set, or the combined blast affected population, which we take different percentages from the different blast overpressure zones. And they're not necessarily casualties, it's sort of a cumulative metric of damage.
Thank you. Okay. Now, define affected people.
So we used, let's see, it was 10, 30, 60, and 100% for the different overpressure levels of the number of people in that zone.
Function of the PSI. Blast.
No, it doesn't necessarily mean dead. You can have, yes, you can have fractions of people that are affected but not dead. So it's a metric. You could define it another way. This is the one we used.
I think it's a good metric because affected could be injured, and in fact, these are voters. Okay, so the injured will be very unhappy with the politicians at some point. Okay. One last point on here, and I'm sorry. They certainly could be evacuated, yes. What we're seeing here is, I can't read the actual number here, but there is a greater chance that 1 million people or more will be affected than no people will be affected. Did I get that right, Donovan?
Yes.
So the greatest histogram here is that 1 million people will be affected with this impact footprint, okay? Did I have a question, Andrea?
Can you show again the previous one? The previous one.
Previous one.
I have the impression we have a question which has never been asked before.
Yeah.
I think there is a question. This figure raises a question I think has never been answered before. Can mankind be interested in deflecting to the ocean rather than deflecting to not hitting?
An excellent question to be considered by the decision makers. If you can only do a partial deflection, is this where you might want to put
Maybe
the
you spend
impact
half
point?
of the cost, something like that.
Very good question. I need to move on because this is the main topic that you all need to consider today, okay? And so I need to outline the possibilities. And Brent Barbie has helped me a great deal with this, and he has slides that he will show his group. Over the last 18 months, the UN Space Missions Planning Advisory Group, same page, has been very active in advising for and coordinating an international program of space missions to reach this asteroid. There are several types of space missions, and we kind of outlined them yesterday. We're going to kind of narrow them down today. But basically, there's these 4 types. Early, fast flyby characterization, and that was approved yesterday. So we have that spacecraft under development, and it's going to launch in only a year. It's fast, so it arrives at the asteroid in less than a year. So that's approved and will fly, but we were thinking of whether we should have 2 spacecraft. That's a question. one or two spacecraft is a question for you all to consider. But that's ready and on track to be launched. The second type of mission, which I think you approved yesterday, was a rendezvous characterization mission. And it's characterization, and it would be an observer spacecraft to observe the kinetic impactors to see what they did to move the asteroid, okay? That is due to be launched in June 2020, and it is also under development. I was given instructions yesterday that the decision makers said so they would fund this. So over the last 18 months, that has been funded, and there are 2 spacecraft ready to be launched, but you need to tell me how many should be launched, okay? So that's up to you, exactly. In fact, you don't have to launch any of these. I'd like to know at the end of this discussion how many of these you actually want to launch, but these are ready to launch. Now, kinetic impactors. That's all right. Yes, are they identical or different? And what about the launch vehicles? Are they the same or different? Please consider that. Kinetic impactors, eastwards or westwards? Now I'm calling that KI east and KI west. The eastward ones would launch in March 2020, which is very soon from now. Why is that? That's because it's a hard orbit to attain, okay? To go eastwards is the difficult direction, which I'll explain in a minute. Going westwards is easy, and it can wait until July 2023. The deflection time is very similar. Now, the question is, how many spacecraft should be launched? And that's something for you all to consider. We will show you that you need to have several working in combination in order to get the asteroid trajectory off the Earth. Is there a question, Andy?
Yeah, it was related to this. I was going to ask how many, if you went westward, how many spacecraft do you need to dump it into Central Asia?
All right, I'll show this a diagram in a moment. That's an excellent question. Let me tell you first that you can do this yourself in our NEO deflection app. This is a little advertisement. Because the default object has changed to PDC 17A because we now have a new orbit solution. And you will notice that the location of that impact is much closer to the limb. It's moved from kind of central up to there. And you can actually try these kinetic impactor missions yourself and see what launch vehicles and launch times work. Okay, there's the same blow up. Now, east is this direction and west is that direction. So that orients you when you actually use this app. Okay, now I want to, as you recall, if we put the Earth into the app and we rotate it, here is the money slide. The new location is here. And the footprint, a little bit of it is off the Earth, okay? But this is the footprint we have currently as of this date. So it's a 96% chance that it will hit. The easier direction is this direction, but it's the long way to move the asteroid trajectory. It's going to take at least 3 missions to move it all the way across. I'm assuming a Delta IV Heavy in this case. However, it's a difficult direction to go in this direction. That's the eastwards, is that right? Eastwards direction, and it's difficult in the sense that you don't get as much deflection from each mission. So it's also going to take about 3 to go in that direction to get it off the Earth. This next diagram I've tried to show this. These are representative distances that each kinetic impactor can move the object if it's 270 meters. I took a worst case, okay? Delta IV Heavy, 270 meters. If you go in the the westwards direction, you can move 3,700 kilometers, assuming beta equals 1 and all of these assumptions. That's how far you go. If you go the other direction, each kinetic impactor can only move 460 kilometers, and it's going to take 3 of them to get off the edge. You need to tell me what you're going to do. Which way do you choose to go? And how many spacecraft do you want to launch? I will show you an example of a few of these trajectories. The early flyby mission is here. It's a quick flyby. That's the dotted line is the trajectory for the flyby mission. I don't have the rendezvous mission, I apologize. The westwards mission follows this dotted line here, and you can see that it's kind of interior to the Earth's orbit. It's a really easy orbit to get into. It's an Earth-like orbit. So that's why the westwards direction is easy. You're launching the spacecraft here, and you're intercepting the asteroid at the red dot, just putting yourself in the way. And the asteroid runs into your kinetic impactor and slows down. And that moves you westwards. That's an easy orbit to get to. And that's why you can launch late. Now, if you want to go eastwards, first of all, you have to use a solar electric propulsion spacecraft, SEP. It's a little bit more complicated spacecraft, but we have that technology. Let's see, the asteroid orbit is this purple one. The one with the arrows is the orbit that you would have to get into if you wanted to deflect in the eastward direction. It has to be bigger than the asteroid orbit itself because the asteroid is really hauling when it comes through here near perihelion, and you need to hit it near perihelion. So you need to go faster than the asteroid, which means you need to have a bigger orbit. Does that kind of make sense? So you arrive at with 8 kilometers per second, not as much velocity relative to the asteroid, and so you don't move it as much. And that's why it doesn't move as far in the B-plane. Does that kind of make sense? This is why eastwards is harder. You need to attain that kind of big orbit, and it takes a long time, of course. That's one rev. It's going to take quite a long flight time between launch here and when you deflect. Question? Solar electric propulsion would help you, and Stas can help me if I get this wrong. Solar electric propulsion can help you because it's a difficult orbit to attain, and you need to pump up the energy. I believe that's bottom line. Am I more or less right, Stas?
That's basically right. You can't get enough mass if you don't
Yes.
use a solar electric propulsion.
Right.
So even though you can perhaps get the velocity, you won't get enough mass.
Okay, so one more question, Joe, and I'm going to have to hurry because.
If you go in a slightly smaller orbit,
Yes.
come close to a rendezvous.
Yes, there is a rendezvous. Yes, there is the rendezvous mission as well. Yeah, that's correct. So I'm not showing that one, but yes, solar electric propulsion can be used to rendezvous as well. Yes, I agree. So I have one more slide in which I put all of these together, and it's a slide you need to consider with Brent Barbie's group when you make your decisions. That is the summary of the key dates. Now, here we have the inject date last time, and here we are 18 months later today. Sorry that the conversion from Mac to PC didn't work. Here is the fast flyby mission. It's going to be launched very soon now, okay, right there. And it has a very short flight time. It would arrive in 2020. So you would get very useful information for the deflection missions, which would happen out here, if you saw the asteroid up close. So a characterization mission would be useful, and getting that information early helps the engineers design the deflection missions. Okay? So you approve that mission, and it's scheduled to arrive at the asteroid. There are a couple other rendezvous missions here. You need to choose between these two. Brent will ask you to choose between these two particular rendezvous missions. One launches a little earlier, one launches a little later. They arrive at a similar time at the asteroid. Again, it takes a long time to get into an orbit from which you can rendezvous with an asteroid. So they don't get there until then. These are the kinetic impactors in pink here. The first one is the eastwards one. You have to launch early because you will need to deflect at perihelion, and it's a long flight time in that big orbit. So you need to make a decision and tell us whether you're going to launch that spacecraft. I think that you have been developing it, so you have at least you're partway down the development cycle on these ones. That's the KI East. There are two options for moving it west. They can wait much longer. You can launch here or here. You'll need to say what you'd like to do on those. Now, so the questions that, my screen timed out. The questions that I had listed are the following. How many spacecraft will you launch for each of these? You need 3 of them to work in combination to move it off the Earth. If you have only 1 or 2, you're going to have a partial deflection. Think of the implications of just having 1 work or 2 work. How are you going to handle that? And east or west? That's a key decision. Or are you going to build them both? You can wait for west, but east is a key question. And with that, I think I have established the...
Paul.
Oh boy, yes, question.
Question, are there any credible deflection scenarios that miss the Earth that we would have to worry about an impact on a subsequent rev?
Yes. If you miss the Earth, you may drop yourself into a keyhole. I am not considering that, much as I love keyholes. I'm not considering that because the probability of being in a keyhole is much smaller than the probabilities we're dealing with here. So let's just deal with the problem at hand and solve this 2027 issue. Okay, last question.
Easy question.
Good.
Who is releasing the press release and who wrote that in the scenario? Who is the person releasing that? An institution and which country?
The communications group would release it. In reality, I wrote it, but the communications group would release that. I think, is that the answer? Oh, I1 releases it. Yes, excuse me.
Releases it.
I1.
So
So the
I1 is
I1 group.
talking on behalf.
Yes.
Okay. And
Okay.
then your slides are slightly different than the one on the web, just for your information.
Okay, thank you. Mark Boslow would talk about impact effects. I'm sorry. Okay. We'd like to hear about the impact effects, though.
I'll make it really, really short. So a question came up yesterday in conference time, 18 months ago in simulated time, about infrastructure, and my colleague Bill Fogelman, who has access to open source information on infrastructure, has put together a bunch of maps. So each one of these maps has a different sets of infrastructure. And he's got a table at the bottom, as you can see. So there are 4 countries affected: China, Japan, and the Koreas. Most of the affected infrastructure along this corridor is in Japan. Now, we can provide blow-ups of all of these if you want to see them in more detail. Now, I just want to say a few words about tsunami because that came up earlier. Just for perspective, here is a tsunami simulation offshore. And this is maximum tsunami height as a function of position. The reason you have high places is because of bathymetry that causes some focusing through refraction. So that gives you kind of the perspective on it. I do have an animation of this, and there it goes. So this is actually a point about 400 kilometers offshore. I provided wind fields and pressure fields to my colleague Vasily Titov, who is at the United States NOAA Tsunami Research Center. And he used the wind fields to drive a tsunami, and that's the primary driver of tsunami from an impact or an airburst. And what he found was that the tsunami run-up and area affected is not strongly dependent on the distance of the impact from Japan. So as you push, if you push it to the east, you really do not affect the size of the tsunami hitting shore too much. How big are they? They're about 25 to 29 meters maximum height when they hit the shore. Those are the intense red, dark red places. The flooded area affected is on the order of 50 square kilometers. So I disagree, I think, quantitatively with Lorian, but I think the bottom line is the same. You want to get it far enough. If you do decide to push it east, you want to get it far enough away that the air blast does not affect the people, because that's really the dangerous part. And the reason is because if you do the same thing with infrastructure that Bill did for the risk corridor, if you do it along the shore, there aren't a lot of people, and there isn't a lot of infrastructure along the shore here, and there's a huge warning time. It's not like the 2011 Great Tsunami where there wasn't warning time. There is warning time, so the effect on people is that they're going to need to be evacuated. So I'll stop there.
Okay, I told you he was doing bad things when he was asleep there, or not asleep. So basically, we've got. I think what we ought to plan to do is go ahead and have the groups go out. Yes, quickly.
Yeah, one quick question. Do I understand correctly, Mark, that we will have only air blasts, airbursts over the ocean, or will we also have surface impacts?
Surface impacts as well. Surface impact, right. Yeah. Okay, so I would propose that we have the groups go out and come back here at quarter of. So that would be 5:45, and then we'll plan to spend a half an hour. We're going to be about 15 minutes late, but it sounds like this is a good one to discuss. Yeah, I'll put the distribution thing. That's group, let's see, group 4. Is group 4 back yet? Okay. And Brent, is Brent here? Would you suggest we go ahead without Brent? Okay. It looks like the same page. People aren't on the same page, is all I can say here. Ah, yes, I understand. Okay, well, as I mentioned, we've expanded our leadership group here, and so that should be interesting, and I think all of the groups are here now, right? We'll find out. Okay, so why don't we go ahead and start with group 1, and let's just work our way down this thing. So who's representing group 1? Ah, perfect. You want to use it this way, or you want to hold it?
I guess I'll use it. Good afternoon, world leaders. Thank you for assembling. My name is Curtis Suwata, representing our panel of esteemed scientists and experts on characterization. And today we have 3 recommendations for you. First, we must continue using all available ground-based assets and space-based to continue characterizing this asteroid headed our way. Second, a successful flyby is critical. This will tell us, first, it will reduce the impact uncertainty in terms of where it will land on the Earth, and it will also help us understand if it's a specific type of asteroid, a binary, the shape, and whether it's an outgassing type. So this will help inform our future missions going forward. And finally, third, the rendezvous mission that we're designing for right now is critical for us to understand how heavy it is, and also to be able to understand how well we deflect the asteroid in the future. And so we must design it with some redundancy in mind, so that even if one fails, we'll have something else that will be able to characterize it in a rendezvous mission. And if we have any further questions, we have experts here to field those for you. Thank you.
Okay, thank you, Curtis, for keeping it to 3 bullet points. We appreciate the directness and giving us the bottom line. We have several questions for you. To your first point, yes. We've unanimously decided to grant you all use and funding you need for Earth and space-based observational assets, so please carry forward with that.
Thank you.
Second is on the flyby mission. Mm-hmm. Would it be possible or useful to send something like the AIDA mission to determine deflection capability? I think you called it beta before.
Thank you for the question. I'd like to bring upon Marco, who is our expert.
Okay, so you are asking specifically if you want something like AIDA, so like what? Both components, like
Right.
A flyby and
right.
a small impactor.
As a small impactor.
Like
we realize that we cannot yet launch a kinetic impactor
Yeah,
at the time of
but-
flyby for full-scale deflection. Would it be useful to, and could you, launch AIDA to determine the efficiency of a kinetic impactor, or would that give you useful information to do that?
I think, well, we haven't evaluated that part, but I think it could be useful. So yeah, the design is there. It's a mission that has been studied in great detail. So probably it's a good idea. It's going to do something. Okay, it's going to be at least give us the idea exactly of how the object reacts to an impact that we can scale more easily.
Wonderful, thank you. All right, there you go. Thank you. Okay, next question then is how many flyby designs do you have available to us?
Currently, we have 2 in the design right now, and we're definitely suggesting that this must be successful, but
Right.
we defer this to the mission design team to determine whether this is enough for it to be successful.
Okay, thank you. And then for the rendezvous missions?
Yes.
Let's see, we have, where's our, there we go. We have several questions about the rendezvous missions, and I'm going to pass this to our scribe who has more thorough details for us. So you're looking surprised. We did not for rendezvous. Okay. So then I will try to remember what we had.
Okay.
We had questions about the types and number of designs for rendezvous missions that are available, and also launch vehicles. How many launches can you do, and when can you do them?
For that, I think we will defer
sorry,
that to the
wrong-
mission design team.
I'm sorry, wrong group.
No problem.
So how many designs do you have available?
That I will defer that to the mission design team as well.
Sorry.
We're just suggesting that the rendezvous mission is
important.
critical
Okay,
for
so you-
characterization and
Okay.
for follow-up.
But you're not the ones involved in mission design
Actually,
for that.
one of our experts does want to comment.
Yeah, I think there's just one additional recommendation for the rendezvous missions that I may or may not have been covered. We'd like to make sure that the rendezvous missions last long enough that they are operating through the time of the deflections, through the time of the close Earth approach, so that they are operating after the Earth approach, so that they can be used to help figure out, if future encounters will occur or not.
Okay, thank you. Okay, thank you, we're done.
Thank you very much.
Bill, could you time us? Okay, thanks. Then could you give me a hand signal when I need to, at 1 minute? Thanks.
All right, good evening. We've met with our impact experts, and we've determined that the worst case scenario is 22 million people affected for the sizes and compositions that we're expecting. There's about a 45% chance of more than 1 million people being affected. However, there is still a 35% chance of no damage if it impacts in the ocean far enough away for the blast zones not to also overlap the land. The land impacts are really where we're getting our severe damage, and while there is still some disagreement in the scientific community about the specifics of how much damage tsunami could cause, we all agree that a water impact is far preferable and that the tsunami damage is relatively negligible compared to the land damage. So in light of that, we recommend attempting an eastward deflection and prioritizing the early launch for that. The average damage radii that we're seeing for these are in the 100 to 150 kilometer range, and on a worst case, it's around 250 kilometers for these sizes and compositions. So if a deflection can move the impact around 460 kilometers, which Paul showed in his briefing, we would maybe need 2 to 3 successful deflections to get it into the ocean, but I would recommend that you talk to the mission planners to get specifics on that, since I don't have the details.
Thank you very much. Question for you, do you foresee anything in terms of global impacts if it were to strike the ocean? Would it affect climates, harvests, anything like that? Do you know? Or is
Not
that
at
for
these
another-
energy levels, no.
Not at these energy levels.
If it was coming
Excellent.
in a lot faster, possibly, but not.
But you're
not for these,
fairly
no.
confident that the effects would be minimal in the ocean from all sources.
Yeah.
Okay. Thank you very much. Oh.
tsunami affect in particular
Nuclear
nuclear
plants.
plants?
That's for a different group. That's for a different group. Thank you. It's for emergencies. Emergency response. Hi, okay, so I'm representing the deflection group. One of the major judgment calls to be made is whether to deflect east or west. Going west is easier because you're just getting in the way of the asteroid, and you can wait longer to launch in those cases. We talked about the additional operational risk associated with going east. You'd have to build things faster, and the mission design is more complicated and longer. It's a longer period of time to get there. So that was in the minus column for going east. And we also like the redundancy of 2 separate launch dates for going west. However, several people mentioned the political aspects of going west because you're covering more countries, and that could be an issue. I'm sorry, Dr. Brooks-Sayal, we have a lot of really nervous leaders up here. Could you please give us the bottom line? Sure. So we would recommend, ultimately it's going to be with the mission group, which is talking next, but we recommend going for the eastward push, build things as quickly as possible to get ready for that. If things can't be launched in time for that, the westward option is still on the table. There's 3 more years of build time for that to be done. But there's one other important comment, is that the idea of trying to execute a precision hit in the middle of Central Asia, we thought was very unwise given the uncertainty in the efficiency of the push. Okay. I believe we had some questions from the floor. We'll have to make it very, very quick. I think you had a question, and I think, Ed, you had a question. Okay, you didn't want to talk about alternate options?
Oh, yeah, well, okay.
Let's see,
Yeah.
your second.
Go ahead.
Yes.
Quickly, because we're worried of economic world collapse, would it be possible to do both? To plan and possibly launch for east and west?
Yes, but their encountered times would be the same. So you would need to make a judgment call within the months before that, which one you wanted to do.
What are the chances it could fail if you launch and you're trying to push it eastward? Is there a launch opportunity afterwards if you try this and it doesn't work?
No.
What is plan B?
Well, one potential plan B would be, this would reside with the mission group, but with the rendezvous mission, if they bring a nuke as a backup. Okay. So you'd advocate adding a nuclear device to the rendezvous mission? We would, and possibly 2 to have redundancy. Okay, thank you. Okay, the question from the deity is that, Paul is the deity, he's the threat master, okay? The question whispered in our ear from the fates is which do you recommend? Which is more favorable, a kinetic impactor or a nuclear deflection? Nuclear would work with 1 shot. Kinetic would take, we know, 3 to miss the Earth, either direction. And so in many ways, the risk is lower with the nuclear case. But ultimately, the decision will rest with you, which is more appealing. Okay. Thank you very much. That's very helpful.
Okay, same page.
Okay, so we were designing this mission with
Please use the mic.
Okay, so we are designing this mission with cost and reliability consideration. You pretty much have 2 options, and one costs $2 billion, and the other one costs about $8 billion, or maybe even more. So for the first option A is you have 2 active rendezvous ships armed with nukes, and you're trying to make June 2020, you're doing June 2020 launch. You already committed you're launching your rendezvous ships. You just have to decide whether you want to arm them with nukes or not. That would be, quick fix. Number 2 is you send 2 passive rendezvous ships. You need backups. And so in this case, you are relying on kinetic impactors. So you're planning for both. You're planning for eastward deflection first. In that case, you are trying to make 2020 launch. And your rendezvous ships are launching later, 3 months later. So you are running blind. You're going there with your kinetic impactors, but you will not know how your asteroid looks like. Which is fine, because if you don't make that March 2020, if you're not ready for your launch, you're preparing, basically, you just repurpose them for 2023 launch in a westward direction. So in that case, you are already going to have 7 weeks worth of data from rendezvous ships, and that way, and you are going to know exactly how many kinetic impactors potentially. We know it's 3 in each direction, so we propose 6 of them total as a backup. So there are ways to, and so yeah, so those are your options A and B. So go just pure rendezvous ships with nukes, or rendezvous ships passive with kinetic impactors.
Do you have the manufacturing capability to do both?
To
A and B?
Well, the only difference is whether you put the nukes on or not.
Okay.
So.
Question?
So it's kind of, do you want to build kinetic impactors or you don't? I mean, yeah, potentially you want to do backup, you put the nukes and you do kinetic impactors?
We had a question as, how many kinetic impactors can we launch? If 6 is not enough, can we launch more?
So how many can you build?
Oh, how many can you build?
And how many can you launch in the time frame that you have the launch window?
Well, you're probably going to be distributing that over countries that have that capability, and maybe each one would build 2 at the time. So I would say just between China, Japan, USA, Europe, you could potentially have 8 kinetic impactors being built.
To Sampage opinion, if we do not think about the cost, which method would be the one that would get this problem away the fastest way possible?
The fastest way you do everything. Then you pretty much put the nukes on your rendezvous ships, and you also start building the kinetic impactors at the same time. So you do everything.
Okay. Any further questions?
Maybe I will enlarge that remark only. What is the probability of launch failure? And the other question is, so how many launchers we can build? Because if there is a need to build, let's say, 20 launchers, the point is to deflect the asteroid, not to spare money.
Well, we know we need 3. We need 3 successes. So it is, I think, times 2, 6 to 8 kinetic impactors that should provide plenty of redundancy.
And your probability of failure for each given launch?
50%.
50? 50?
I'm sorry.
So much.
I'm sorry.
5%.
Okay.
Okay. Thank you very much. That's very helpful. All right. Next advisory group, please.
I'm Tim Spar. I'm from the Decision to Act group. And we have 4 recommendations for you, and we'll just get right to the point. We recommend supporting the East deflection missions immediately. They have to be launched. We don't have enough information about where the object's going to launch them. We also advocate for nuclear weapons on the rendezvous spacecraft, full stop. At this point, with the lack of information, we have to keep all of our options open. So we need the ability to nuke the object, push it east, or push it west. The 4th point is that is an extraordinarily complicated situation, and this needs a political body of some kind to help make those decisions. And it's complicated in the sense that it's going to involve spacefaring nations that aren't the nations that are in the impact zone. So you're talking 8 countries, 10 countries that are involved in that complicated scenario, and you might have the case where you have the ability to do multiple deflections each direction and it's extremely complicated. So we recommend the formation of a body to help sort out that problem.
So we need coordination through our World Treaty Organization in order to time the deflections, is that, or the attempts, or determine the direction?
Determine the direction,
Okay.
yes.
So to set up a CONOPS, basically. Yeah.
Yes.
Okay. Thank you very much. Do we have any questions? Yes, sir.
Thank you for your plan and the presentation. And you touched upon some measures, and including nukes. But in this region, this is very sensitive issue. So if we propose this, it will trigger the heavy debate and it will consume time. So I think that we should concentrate on the conventional measures. So we have a lot of possible measures. So this should be first, I think.
Okay, I agree with that. Yeah.
Thank you. Thank you for your advice. The next group, please.
Hello, I'm Maria from Communication Group, and we decided to say the next, that we need clear, concise, and consistent information available for publicity. Also, we should be ready to start answering the big questions from the populations about the kinetic impactor, how it works, and about kinetic impactor mission. People should know that communication will occur through established processes with the UN to understand, monitor, and plan. People should be sure that that everything will be okay. That should be sure that we are ready for this and that the nation are working together. We have the technology. We are doing everything to prevent the disaster, and we are ready to preserve their lives. So the situation is under control and okay, but you should be ready for challenging questions like, how do we know you're right? Does this asteroid exist or not? Are we using nuclear weapons? You should decide this, and you should be ready to answer these questions. And how is going to pay for all these missions? Who is going to build them? And what if the mission aren't successful? And do you have a plan B? That's
Okay.
all.
Thank you for that guidance. We have a couple of quick questions for you. So our populations are terrified when the probability of impact jumped to 26% 11 months ago. The impact corridor leaked to the press from somewhere within the community studying it. And so now people are keenly aware of which areas are part of the hazard ellipse and which are not. This has had tremendous economic effects, tremendous panic. Some of us have already been through elections. You see some new faces here with us. And the rest of us are hearing daily from many of our constituencies. The switchboards at my government offices have not actually stopped ringing since that time, and things are only getting more intense. So how do we deal with the leaks, and how do we deal with calming people down?
I think you're wise people, and you should decide where it would be better to put the asteroid. Will it be ocean, or it will be desert, or it would be somewhere else? So it depends of your decision. It I think people shouldn't be concentrated of where asteroid is going to be now, but where it is going to be after our actions. So.
Okay. Thank you very much. That's very helpful.
Thank you.
Any further questions? Yes.
If we choose to put a nuke on the rendezvous mission as an option B,
Sorry, again, please.
If we choose to put a nuke on the rendezvous mission as a option B, plan B, should we tell the public?
Yes, I think we should tell the public something like all the countries made a decision together and they are ready for this and they're friends now. So
Thank you for your guidance.
thank you.
Okay, next group.
Check. Okay. Hi, I'm Phil Groves with the Disaster Planning and Management Group. And our main mission statement is everyone gets to live. We're going to plan for hopeful mitigation efforts, but otherwise we're going to put in plans on how we address should the asteroid actually strike. And a key date for us is the year of 2024. We'll be a lot smarter. We're starting to draw plans on how we're going to move populations and relocate them. This is not a refugee problem, it's a relocation issue. And with that comes the other initiative of coming up with arrangements to develop an economic sort of regrowth area as a contingency plan, a form of insurance, if you will. And it's been a real relief for us in this group to hear from our scientist friends that they're recommending to move the asteroid eastward, because like you would put a fire break in front of a fire, that's the best recourse to help ensure that even if the asteroid strikes, we don't have to deal with the consequences or as severe a consequence as we might have. Also having some international programs to have inter-country cooperation, as well as the countries that are in the path of the current risk corridor, because we can expect that there might be cross-border issues depending on where the asteroid strikes. And you guys are going to have to do something about that nut job in North Korea. So that's in your hands, so we'll leave that to you. So I think that's pretty much the game plan as we see it right now. And we're drawing up plans. They're far too detailed to get into for this discussion on how we move people, how we set up infrastructure within the various areas in the corridor to deal with a relocation program.
Thank you. We have some questions for you. First being, if we go with an eastward deflection, there's a small chance of a tsunami inundating the east coast of Japan. We're aware that that area has already been inundated with a large tsunami, and there are damaged assets there that may pose hazards. For example, the Fukushima nuclear plant, and we wanted to know if it was re-inundated, would there be a radiological risk, and what would that look like? Or are there other assets that pose a similar hazard?
So a course of action in case of a tsunami?
Correct.
Well, we're going to pass out bathing suits. That's if everything goes well. We have another iteration of our evacuation planning in the event of a tsunami, and also a refinement of the economic planning in case the coastal areas need to be handled in this sort of contingency way.
You'll forgive me, Doctor. I believe you that people can be evacuated, but I'm not aware that it's possible to evacuate the reactor cores as they are currently underground and inaccessible. What happens if they're inundated and disrupted?
The nuclear reactors?
The reactors at Fukushima, correct.
That's a good question. I don't know if any of my colleagues on our management have any answers on that.
At this point, the impact corridor does not include hitting Fukushima. It actually will miss that, number one. Number two, it's coming in, if we do get the asteroid out east, the area that will be impacted, the modeling that we've done shows that the risk to the area was not going to be great. It'll be pretty minimal, just based on the seafloor and whatnot. So, but as far as what would happen with, specifically with Fukushima, we'd have to bring in the experts who deal with radiological issues, and we do not do that, but we'd certainly bring them in and get their advice and then pass that along.
But it's not in the inundation zone? Is that what you're telling me?
At this point, it is not.
It is not in the inundation
zone. It's
zone?
further east.
Are there any other assets that might be at risk?
This, I wish we had our maps up, but we really don't. There's not much in that area.
Good.
And we also have
Very little
coastal, the way the
infrastructure.
coast is at a grade that prevents it from doing too much damage.
Thank you, that's very helpful. Do we have any other questions? Yes.
Yeah, we understand that there's been a terrible economic crisis, far exceeding the Great Recession that we've had as a result of the fears that major damage will happen in China or Japan. And so you're dealing with this right now, and is the expense and other issues associated with that major economic crisis that's happening already going to interfere with your abilities to carry out what you proposed?
Well, we're developing an economic response, and part of our planning before 2024 is to actually put in programs that help stabilize real estate prices and other sort of stabilizers for economic pressures.
Let's see, you have a comment on that. Would you like to do it now, or can we hold it until it's our session?
I think it is our session.
Are we next? Yeah, we're next. Okay, then thank you very much.
Thank you.
And then I'm going to yield the floor to my colleague for, I'll give you 3 minutes to discuss the economic impacts being felt around the world. 3 minutes, please. 3 minutes for this speech. Yes, total. Oh, 15 minutes for us and 3 minutes for Ed's speech, please. Okay, I yield the floor.
Just something to point out is that the economic damages, the economic distress may start immediately upon the announcement, and not after an effect, but immediately if there is a drop in real estate values along the risk corridor. And the reason is that nearly all bank loans eventually tie back as collateral to real estate. And if there are not buyers for real estate, then the price becomes uncertain and it can no longer be used as collateral. And if there is no longer permissions to do permitting for major infrastructure projects, they don't get approved. And if real estate values become uncertain, then banks, because of their capitalization requirements, must call in their loans. They don't have a choice. And that's a bank run. And that's what happened in 2008. It isn't that anything necessarily changed other than an unwillingness of buyers because they are uncertain of the value of things. So it is possible that you go into an enormous recession, the way something like we had in 2008, or perhaps worse, and that world leaders could end up having had their hands tied. They must move quickly because the economic pain might be many orders of magnitude larger than the cost of flying any of these deflection missions or something like that. Like 2008, we're looking at $1 trillion cost of this bank run, right? And so if that could utterly dwarf any of the considerations about treaties or whatnot. Just depends what happens.
Okay, thank you very much. All right, so do we have any other statements from the floor? Does anyone else wish to speak? No one else wishes to speak. All right, we wish to vote. I will agree with that. We have had an extremely stressful time of it as world leaders. There have been a few elections already indicating a preference among our constituents for extremely decisive action. We've had speculation, rumor, leaks. We've had economic crashes. We have severe problems, and with each $1 trillion of lost value to our economies, we are losing approximately 250,000 of people from that, just from the economic impacts. So we have people who are already dying from this impact, and it's still 9 years out. We have resolved that we need to begin swift and immediate action. We support the slogan, no fatalities. In the UK, our colleagues who are fans of Doctor Who may remember the slogan, nobody dies. And that is our goal, is to keep our people safe and not lose any more lives from this object. So we have some decisions to make as leaders. In our closed session, I believe we tabled several actions. The first being that we unanimously support all Earth and space-based observation assets being focused on this issue at this time whenever they're needed. We are willing to spend the money on that and support that fully. The second being the rendezvous missions. We decided, I believe, in support of 2 rendezvous missions, but now the question is for the mission team, our desire is that this object have a constant companion, preferably 2 constant companions for the duration of this hazard. As long as we are held at risk, we want to watch it. We want surveillance, we want a beacon telling us exactly what it looks like, where it is, what it's made of, everything we need to know. So for the mission team, we want to know what would it take to do that. Dr. Barbie, please wait for the mic.
So we anticipated this, and we've already designed the rendezvous missions to meet that objective.
Fantastic.
They will last throughout the duration.
Okay.
Yep.
How many had you planned for?
2.
Can you build 4?
We'll have to confer and get back to you on that.
Please do.
Keep in mind that it's now November of 2018, and we're looking at a June 2020 launch. Just to field 2 reliable rendezvous ships in under 2 years from construction to launch is utterly unprecedented as it is. So
Okay.
we'll have to take that.
We'll take that
very
as a no
carefully.
then. 2 it is. All right, let's vote on the 2 rendezvous missions. Do we support with money 2 rendezvous missions? Yay or nay? Yays, raise your hand. Okay, unanimous. The second question was the recommendation to field nuclear devices on the rendezvous mission with the idea of potentially deploying a nuclear deflection. We had resolved to vote on that. We do, however, as part of the World Treaty Organization, have a filibuster clause in our agreement. So given the questions raised before, I would like to respectfully ask my colleagues from Japan, do you filibuster the motion for adding a nuclear device to this rendezvous mission?
Thank you, Chair. I remember this January, we have the very sensitive film in Japan. And in the film, the monster Godzilla destroyed Tokyo and then tried to destroy Japan and the rest of the world. And the leaders tried to decide to use nuke. However, the excellent scientists appeared and they used biotechnology and stopped the Godzilla and the world was saved. So we can develop the lots of measures. So we should not confine the argument, and also please understand this is a very, very sensitive issue here. Thank you.
Okay, the use of a nuclear device on the rendezvous missions has been filibustered. This community will not vote on the use of nuclear devices on the rendezvous missions. All right, we have kinetic impactors. We have discussed the potential for fielding kinetic impactors. The voice of God. The voice of fate.
I just want to say there are other entities involved in that decision too, because you basically, if something goes wrong, there'll be much larger populations that would be affected than just those in Japan.
That is true.
I think that individual nations may choose to do what they need to do for their people.
Oh, I'm sorry, Ed, please repeat that.
I don't agree with your statement at all. I think that individual nations may just choose to do what they need to do for their internal politics that have nothing, that is irrespective of what other nations do.
I agree with you. However, we as a treaty organization are bound. If a nation chooses to secede from the treaty or to conduct a launch on their own, that is their own prerogative, launching from their own state. There may perhaps be consequences, economic, legal, we don't know that, but this body will not vote. Russia, one moment, please.
Now I'm not only representative of Russia, but also physicist. The kinetic impactor is absolutely insufficient for changing the trajectory or preventing collision. The only option is to use standoff or offset explosion of some nuclear bomb. Nuke could be as low as 100 kiloton. It means that it is just ordinary, not special thermonuclear and so on. But just from the point of view of physics, you have no other decision. And most efforts should be concentrated on to have this decision by all nations. We should attract United Nations, should insist that United Nations establish a special committee, special group, steering committee, which will be accepted by all the humankind. I just calculated this, that it's no problem.
Thank you. I'm sorry, we're short on time. All right, resolution to form a committee. Ayes, raise your hand. 1, the motion fails. All right, all right, I will ask, will the gentleman who filibustered the motion withdraw their filibuster, or does the filibuster stand?
This is the conference which was held first in this region. So I do hope the motion will be adopted in unanimous or in consensus. So this is what I would like to say.
So you will allow the vote, yes or no, on the nuclear? Will you allow us to vote on it or no? You say it's too early. You will not withdraw your filibuster. All right. So, kinetic impactors. You do support, okay, let's re-vote on the committee. Do we have a yes? Do we support a committee recommended by Boris to study the nuclear question? I don't think it's to study. I thought it was to be able to act. Not to act, to study. We're filibustered from voting on acting. All right, voice of God, and then we got to get moving. We got 4 minutes.
The next inject will happen after the launch of the rendezvous missions. So a decision is needed now on whether or not the rendezvous missions carry a nuclear device or not.
Okay, we're filibustered.
And that may make a big difference in what happens tomorrow.
Okay.
Is there an option for using a nucleator?
Is there an option for using a nucleator? Brent Barbie.
The nuclear devices may engage the target in one of 2 modes, either in a hypervelocity intercept or post-rendezvous. Post-rendezvous is technically more credible because it doesn't involve the challenges of precise detonation at hypervelocity approach speeds. However, if the rendezvous option is foregone, the option to then attempt a hypervelocity proximity detonation on a subsequent launch attempt remains. There are also solar electric propulsion trajectories that could rendezvous it.
Thank you, we're short of time.
You could rendezvous later and do a detonation.
Thank you, cut his mic, please. All right, sorry, Brent.
But you would be blowing the asteroid
up. All right,
up.
We have votes to take here. Kinetic impactors. It sounds like we can manufacture between 6 and 8 of them, launching 3 at each time. Can we launch 12? Or can we manufacture and prepare 12? The man I just cut off. Yes or no? No. Okay, thank you. We can do a maximum of 8? 6. A maximum of 6. At one time. You can build a maximum of 8. Okay? All right, so are we resolved to build a maximum of 8 kinetic impactors? Yes. Okay, are we resolved to have multiple designs for technological variety and failure modes. Okay, we passed that. Multiple designs, maximum number of impactors. All right, are we, huh? East, yep, that's what we're getting to next. Thank you. All right, are we resolved to take the recommendations of our technical experts and favor an eastbound deflection? All in favor, raise your hand. Thank you. Are we resolved, as we previously discussed in closed session, to hedge our bets by also considering an westbound deflection? Motion carries. All right. Did we have any further, 1 second, did we have any further motions to vote on? Right, okay, flyby missions. Whatever you can launch us, you got the money for it. We need a jobs program. All right, Scribe?
So we also had some discussion about economic impacts and whether we wanted to establish a fund, have a recovery zone, freeze the markets. Those were the three.
Okay, let's see. Ed, you already spoke about economic impacts. So do we have a motion to do something, and we will let our economics people guide us about something for stimulating, stabilizing the economy? And I'm leaving that deliberately vague because we got 3 minutes. Okay, motion, what was that again? I don't think that motion carried. That failed. Okay, no one can control it, motion fails. All right, we had comments from our leaders. We have 2 minutes. I'll give you 30 seconds each.
We have to go back to this nuclear question because we have to decide to carry them or not, and you don't have another option later on the rendezvous mission. So I would vote that just because you carry them doesn't mean you use them, that you design them in on your rendezvous missions. We then will perform the kinetic impacts. In the event that they do not work, we have that plan B there to save the world.
Thank you very much for your comments. I will respectfully remind you that we have been filibustered and this treaty organization is unable to vote on the nuclear issue. However, the choices you make in your own country are not strictly controlled by this organization.
Yeah, I just like to emphasize that point. I think we should go along with our rules and procedures in the treaty organization, but I think we should acknowledge that other countries may choose to go their own way. And so, I mean, Paul wants to know, are there going to be nukes? And I'm afraid there may be.
All right, then I am going to rip off the Band-Aid. Do we have any rogue nations that are proposing to launch or secret something onto a rendezvous mission? Just so God knows. All right, we have 3 nations who are making side bets.
If I was a leader who's had that capability and whose country was threatened, I would do it.
There's only one country that's threatened.
Again, I think they would seriously consider it.
All right, then I would like to respectfully yield the floor to my colleague from China. Does your country have the inclination to launch a nuclear rendezvous mission?
I think, excuse me, I think based on the current knowledge, I think we will not build a nuclear weapon for that. Yeah, but we're gonna maybe do some science prepare study for that, and as a resource, and then we will decide after 11 months. Yeah.
Thank you. So my understanding is that China will not launch a secret nuclear rendezvous mission, that you will watch and study and be prepared for a potential later nuclear intervention. In that case, unless any other nation is going to go rogue, and very quickly go rogue, because God needs to know.
Yes, so what stops us from a few nations who want to have the nuclear option to go rogue together, create a committee and vote on using the nuclear option?
You would go rogue together, you would not vote in this body because it's been filibustered. If you want to go rogue together, speak now. Do we have a rogue? We have a rogue. All right. The voice of fate. Let's leave it at country X so we don't pick on anybody.
Well, a possibility, of course, would be to have the committee work with the affected parties and keep the option on for a later launch. And so that would be a flyby version, which was described as a possibility. And so that gives some time to work at it and really see where things are.
But riskier.
But riskier, says the voice of God. That seems to be where we're headed. Okay, we will not then have a official nuclear rendezvous mission. However, it appears there will be a third rogue rendezvous mission. We'll have another decision to make. All right. Do you need anything else from us?
I think you've answered all the questions. I think we're good.
We're good? All right. I will yield the mic to Fate.
It's time to go have a drink, guys. Yeah, this is really an interesting exercise, and you can see why it's useful to do this, because these are tough decisions to make, and we're all among friends, and this is not real. So the decision makers are really going to have a tough time. So I really appreciate the work you guys are doing, and I'll be interested in seeing what you decide next time. So go enjoy the snacks, and look at the posters.